This is one of the 10 math commandments. Thou shalt not write on paper with ink. Subscribe to Mr. Math Inc. I love math.
Fill in the blank square so that each row and each column contain all the digits 1 through 4. Numbers and cages may repeat as long as they are not in the same row or column. So the darkened ones are a cage, so I need 3 numbers that multiply to be 24, 3 to multiply to be 2, 3 to multiply to be 6, 3 to multiply to be 8, and 4 numbers to multiply to be 24. Definitely use pencil. Alright, so my strategy is I can only use the numbers 1, 2, 3, and 4. I like to write that down, super helpful for me. And 3 numbers that multiply to be 2. Well, I'm thinking of 1 times 2 times 1. And in the corner problems where you have to repeat a number, put those apart because they're not repeating in a row or a column. So I'm missing the numbers 3 and 4. So if I do 3 and 4, watch this. 3 times 4 is 12. 12 times something equals 24. That's going to be 2. Now I'm not quite sure if the 4 and 3 are in the correct order, so I can just keep going and then see what happens. 2 numbers that multiply to be 8. Okay, so I can choose 2 times 2 times 2, but those would be repeating numbers. So I'm thinking of 1 times 2 times 4. Now, if I put the 4, I can put the 4 over here, but that means I have to put the 1 and 2 here. So I'm going to try erasing the 4 and the 3. And just switching the orders. Now I can do something like 1, 4, and 2. 1 times 4 is 4, 4 times 2 is 8. And again, I can switch the position of the 4 and 1 later if I need to. Let's keep going. And you could have done this in multiple ways. I'm just showing you what I'm doing. That's the first time I'm looking at this problem. So I'm thinking to myself, 36 has to be like 4 times 9. 4 times 9. So if I get 4 times 9, that would have to be 4 times 3 times 3. Now you'll notice my repeating 4s here, so we talked about how it made me just go back and switch these two. So I have 4 and 1. Okay, so that's 12, and then 12 times 3 is 36. Now I just need to fill this in. 4 numbers that multiply to be 24. And basically what I'm going to do here is think about where I can place the numbers in here. So notice how you have to have a 3 in each of these columns here. I'm missing a 3 here and here. I can't put the 3 here because it's repeating, so therefore the 3 has to go here. Let's see if we see some other numbers that are like that. How about the 2s? 2, 2, 2. We're missing a 2 here. Can't put a 2 there, so 2 has to go here. We're missing a 1, 1, 1, 1, so the 1 has to go there. And of course that one has to be the 4. Let's double check. 4 times 3 is 12, 12 times 2 is 24. Question number 5. With multiple choice, which polynomial function r of x or t of x has a lesser degree? So let's take a look at it. I'm going to try to figure out what kind this is so you can graph it. Negative 2, 15, negative 1, 6, 0, 1, 1, 0, and then right 2, up 3. So I'm not sure. It could be absolute value, but we can double check by our common difference. So let's do that. This would be minus 9, minus 5, minus 1, plus 3. If the blues were the same, then it would be linear, so it's not linear. So let's test now this one. Negative 9 to negative 5 would be plus 4. Negative 9 plus 4 gives me negative 5. Plus 4 and plus 4. So this means it is a second common difference, which means it is a quadratic. If it's a quadratic, it means it's x to the second. So my degree here is 2. Let's test the other side. Now, you could distribute all the way through, 3 times this would be 3, x times x, we add the same base, 3 plus 2 is 5, and 3x cubed. My highest degree there is a 5, so I have 5 and a 2, therefore the highest degree of this problem is this. Alright, question number 7. Which graph could represent the function f of x equals negative x to the third power minus x squared plus 5x? Okay, what I'm going to do is I'm going to just take apart this function and try to figure out all the things that I know, okay? Here in blue, this is called the leading coefficient, and it is negative. And basically what that does is it flips the graph. You can also think of it back in your transformations. A equals -1 is a reflection over the x-axis. Reflection over the x-axis, okay? So that's in blue there. Here in green, you have a third degree polynomial. They call these cubics. And what you want to know from there is that this is a odd degree, right? The easiest one you know is to the first power. All right, something I also notice here is there's no number here without an x. And this would have been the y-intercept. So I know my y-intercept is going to be 0. Okay, so let's construct our own graph. This might be helpful. If I just construct my own graph. Let's construct our own graph. Okay, so like I said, the easiest we know is, usually starts down, ends up as you go left to right. But the leading coefficient here is telling me that it's switching. Okay. So we're looking at the blues now, and then a y-intercept of 0 is going to look something like this. Okay. So let me just go ahead and sketch that graph. I don't know, it might look something like this. The big idea is the arrows. Arrows are super helpful, okay? So and notice I don't have all the other intercepts, the other x-intercepts, but the arrows are super important, okay? Watch. This one has a positive leading coefficient, so I don't need this one or this one. Now this one has negative, I should have done that in blue. This one does have leading coefficients. Okay. So either A or D would be okay so far. And let's see if I can work with it a little bit. Let's factor out a negative x. If I factor out a negative x, I will get x squared minus x minus 5. Okay, what I did, I just took out a greatest common factor. Okay, so what's important in this part I just did is that this has a multiplicity of 1. Multiplicity of 1. How did I know that? Because x here is kind of hard for you to see. Let me see if we can switch colors. It's to the first power. Okay, why is that important? Is because if you set that equal to 0, set it equal to 0, and you multiply both sides by -1 or divide both sides by -1, you have x equals 0. And so both of the graphs have it, but you're looking at its multiplicity there. Remember, this is odd multiplicity, which is a shoot through. This is shooting through the x-axis, and this one is not. This one is doing a bounce or a kiss, so it's not D. Our correct answer is going to be A. I actually did this without using a graphing calculator. Hey guys, let's go over question number 8. Find the following sum. Sum is addition or subtraction. I'm going to distribute the 7 to each of these terms. Pass out the green starbursts to each of these. So that would be 3x squared. The 7 is positive. 2x. 7 again to the negative 5. We'll pass out a pink starburst to each of these terms. This 2 is positive. Into this 3. Okay, let's go ahead and simplify this. I'm just going to multiply the numbers in front, so it'll be 21x squared. This would be 14x, negative 35. Remember, this is multiplication. Common mistake is just multiply the first term. Second one mistake usually is students will try to subtract those. Again, multiply, because there's a multiplication here. If you're stuck with your integers, go ahead and just use your calculator. Let's find like terms. I'll use shapes. Those have x squared. So again, I'm just going to look at the numbers in front. That would be a 19x squared. Nothing there. 14x. And then that will become a negative 29. And that would be choice D. Alright, this problem tells you to simplify. So simplify means the basic math operations: addition, subtraction, multiplication, or division. So how do you know which one it is? You're just going to look in between them, and there's just a dot. So in this case, that'll just be multiplication. And for multiplication, we've been using a rectangle. So how do you know how large to draw your rectangle? Well, this has 2 terms, so there's going to go over here. This one has 3 terms, 1, 2, 3. So you're going to put those 1, 2, 3, and that's why it has 2 by 3. So let's go ahead and we're going to first multiply. So this will be 1 times 2, and x times x squared is x to the 3rd. We're going to keep multiplying. Negative 6 times 2 is negative 12, and you just have no x's, so it's just going to be x squared. 1 times negative 3 is negative 3, and x times x is x squared. Negative 6 times negative 3 is 18, and then there's no x's, so it's x. That was a common mistake right there. A lot of students were doing negative times and negatives and negative. Use your calculator, please. 1 times 1 is 1, so you just have 1x. And then negative 6 times 1 is negative 6. Okay, now we're going to add. If you want to, you can just write all these terms out. So this one has no like terms, so 2x to the 3rd. These two are like terms, so you're going to have negative 15x squared. These two, 18 and 1, they'll give you positive 19x minus 6. Let's put a box around it. And that's our answer.
If you love my pretty much, let's begin to try it with me, and you will get a score. Better score, and then try again with me. Let's begin again right now. Again.